A disconnect is indeed required between the meter and the panel for a 200 amp service. The National Electrical Code, specifically Section 230.70 A1, mandates this. The purpose of this requirement is to provide a readily accessible means of disconnecting all conductors in a building or other structure from the service entrance conductors. This ensures safety during maintenance, repairs, or in emergency situations. The disconnecting means, which is typically a circuit breaker or a fuse disconnect switch, must be installed at a readily accessible location. Readily accessible means capable of being reached quickly for operation, renewal, or inspections without requiring those to whom ready access is requisite to climb over or remove obstacles or to resort to portable ladders, and so forth. This location is defined in the NEC as either outside of a building or structure, or inside nearest the point of entrance of the service conductors. Let's break down these location options in more detail. Firstly, an outside disconnect offers several advantages. It allows utility workers or emergency responders to energize the building's electrical system without entering the premises. This is particularly important in situations such as fires or floods. An outside disconnect also simplifies maintenance and repairs, as electricians can safely work on the service entrance equipment without disrupting power to the entire building. If you choose to install the disconnect outside, it must be protected from the weather. This typically involves using an M3 R-rated enclosure, which is designed to withstand rain, snow, and ice. The enclosure should also be mounted securely to prevent it from being damaged by wind or other environmental factors. Secondly, if the disconnect is installed inside, it must be located nearest the point of entrance of the service conductors. This means that the disconnect should be as close as possible to where the service conductors enter the building. The NEC defines the point of entrance as the point where the service conductors pass through the exterior wall, roof, or floor of the building. The intent of this requirement is to minimize the length of unprotected service conductors inside the building. Unprotected service conductors are those that are not protected by an overcurrent device, such as a circuit breaker or fuse. These conductors are more vulnerable to damage and can pose a fire hazard if they are not properly installed and protected. When installing the disconnect inside, it is important to choose a location that is readily accessible. This means that the disconnect should be located in a place where it can be easily reached without having to move furniture, equipment, or other obstructions. The disconnect should also be located in a well-lit area so that it can be easily seen and operated. In your specific situation, where the distance between the meter and the panel is approximately 50 feet, you will need to carefully consider the location of the disconnect. If you choose to install the disconnect outside, you will need to run the 200 amp service conductors from the meter to the outside disconnect and then from the disconnect to the panel inside the building. If you choose to install the disconnect inside, you will need to run the service conductors from the meter to the point of entrance and then locate the disconnect as close as possible to that point. It is important to note that the NEC also has requirements for the type and size of conductors that can be used for service entrances. For a 200 amp service, you will typically need to use copper conductors with a minimum size of 4/0 American wire gauge or aluminum conductors with a minimum size of 250 kcmil. The exact size and type of conductors will depend on the specific installation conditions, such as the length of the run, the ambient temperature, and the type of insulation used in the conductors. You should consult with a qualified electrician to determine the appropriate conductors for your installation. In addition to the location and conductor requirements, the NEC also has requirements for the overcurrent protection of service entrances. The overcurrent protection device, which is typically a circuit breaker or fuse, must be sized to protect the service conductors from overload and short-circuit conditions. For a 200 amp service, the overcurrent protection device should typically be rated at 200 amps. However, the exact size of the overcurrent protection device may vary depending on the specific characteristics of the load being served. For example, if the load consists primarily of motors, the overcurrent protection device may need to be sized larger than 200 amps to allow for the motor's inrush current. Again, consulting with a qualified electrician is recommended to determine the appropriate overcurrent protection for your installation. It is also important to ensure that the service entrance equipment is properly grounded. Grounding is the process of connecting the electrical system to the earth, which helps to protect against electrical shock and equipment damage. The NEC requires that all service entrances be grounded using a grounding electrode system. A grounding electrode system typically consists of one or more grounding electrodes, such as ground rods, ground plates, or metal underground water pipes. The grounding electrodes are connected to the service entrance equipment using a grounding conductor. The size of the grounding conductor is determined by the size of the service entrance conductors. In general, the grounding conductor should be at least as large as the largest service entrance conductor. Grounding is a critical part of any electrical installation, and it is important to ensure that it is done correctly. Improper grounding can create a dangerous electrical hazard and can also damage equipment. Therefore, always consult with a qualified electrician to ensure that your service entrance is properly grounded. When working with electrical systems, it is essential to prioritize safety. Electrical work can be dangerous, and it is important to take precautions to protect yourself from electrical shock. Always to energize the circuit before working on it, and use appropriate personal protective equipment such as insulated gloves and safety glasses. It is also important to follow all applicable electrical codes and regulations. The NEC is a comprehensive set of rules that are designed to ensure the safety of electrical installations. By following the NEC, you can help to prevent electrical accidents and injuries. If you are not comfortable working with electrical systems, it is best to hire a qualified electrician. Electricians are trained to work safely and efficiently with electrical systems, and they can help to ensure that your electrical installation is done correctly and safely. Electrical installations must adhere to the National Electrical Code (NEC). The NEC is updated every 3 years, so it is important to stay current with the latest edition. Your local jurisdiction may also have its own electrical codes and regulations, which may be more stringent than the NEC. It is important to check with your local building department to determine the applicable electrical codes for your area. In addition to the NEC and local electrical codes, there may also be other regulations that apply to your electrical installation. For example, if you are installing a solar power system, you may need to comply with the requirements of the local utility company. It is important to research all applicable regulations before starting your electrical installation. The type of building or structure can also affect the location of the disconnect. For example, if the building is a multi-tenant building, the disconnect may need to be located in a common area so that it can be accessed by all tenants. The specific requirements for the location of the disconnect will depend on the size and type of the building, as well as the applicable electrical codes and regulations. Another factor to consider is the aesthetic impact of the disconnect. If you are concerned about the appearance of the disconnect, you may want to choose a location that is less visible. For example, you could install the disconnect inside a cabinet or behind a fence. However, it is important to ensure that the disconnect is still readily accessible, even if it is hidden from view. The accessibility of the disconnect is paramount. It should not be obstructed by anything that would impede quick access in an emergency or for routine maintenance. This includes ensuring that there is adequate working space around the disconnect to allow for safe operation and maintenance. The working space requirements are specified in the NEC and vary depending on the voltage and amperage of the service. The height of the disconnect is also important. It should be mounted at a height that is easily accessible to most people. The NEC specifies the maximum height for the operating handle of the disconnect. The handle should not be located too high, as this could make it difficult for some people to reach. The location of the disconnect should also be considered in relation to other electrical equipment. It should not be located too close to other equipment that could interfere with its operation or maintenance. For example, it should not be located directly above or below other electrical equipment. The specific requirements for the clearance around the disconnect are specified in the NEC. The NEC also has requirements for the identification of the disconnect. The disconnect must be clearly labeled to indicate its purpose. This will help to ensure that people know which disconnect to operate in an emergency. The label should be durable and weather resistant so that it will not fade or become illegible over time. The NEC also has requirements for the type of enclosure that must be used for the disconnect. The enclosure must be suitable for the environment in which it is installed. For example, if the disconnect is installed outdoors, the enclosure must be weatherproof. The enclosure must also be large enough to accommodate the disconnect and all of the associated wiring. The size of the enclosure will depend on the size of the disconnect and the number of conductors that are connected to it. When selecting a disconnect, it is important to choose one that is rated for the voltage and amperage of the service. The disconnect must be able to safely interrupt the flow of current in the event of an overload or short circuit. The disconnect should also be listed by a recognized testing laboratory such as Underwriters Laboratories or Intertech. Listing by a recognized testing laboratory indicates that the disconnect has been tested and meets applicable safety standards. It's also important to consider the type of disconnect. Common types include fused disconnects and circuit breakers. Fused disconnects use fuses to protect the circuit, while circuit breakers use a resettable switch. The choice between a fused disconnect and a circuit breaker depends on the specific application and the preferences of the electrician. Fused disconnects are generally more reliable and can provide better protection against overcurrent, but they require the replacement of fuses when they trip. Circuit breakers are more convenient because they can be reset, but they may not be as reliable as fused disconnects. The NEC also has requirements for the installation of the service entrance conductors. The service entrance conductors must be installed in a raceway such as conduit or electrical metallic tubing. The raceway must be securely fastened to the building or structure. The service entrance conductors must also be protected from physical damage. The specific requirements for the installation of the service entrance conductors will depend on the type of raceway used and the location of the installation. The NEC also has requirements for the bonding of the service entrance equipment. Bonding is the process of connecting all of the metal parts of the electrical system together to create a low impedance path for fault current. Bonding helps to protect against electrical shock and equipment damage. The bonding conductors must be sized according to the NEC. The bonding conductors must also be securely connected to the service entrance equipment. The NEC also has requirements for the surge protection of the service entrance. Surge protection is used to protect electrical equipment from damage caused by voltage surges. Voltage surges can be caused by lightning strikes, power outages, or other events. Surge protection devices should be installed at the service entrance to protect the entire electrical system. The surge protection devices must be rated for the voltage and amperage of the service. The surge protection devices must also be listed by a recognized testing laboratory. Remember that local amendments to the NEC may exist. Always check with your local building department to ensure compliance with all applicable codes and regulations. Proper planning and execution are key to a safe and code-compliant 200 amp service installation. It's always recommended to consult with a qualified electrician to ensure that all requirements are met and that the installation is performed safely and correctly.